Hello children, in the previous class of measurements and experimentations, we discussed what is a physical quantity and what is a unit and how can we select a unit, and even we discussed about what are fundamental quantities, what are derived quantities and their units we discussed, and the system of units. There only we discussed about what are the prefixes, which are suffixes which are used to express the measurement of length, mass and time. And finally, even we discuss about the guidelines to write the units, children. So that class is very important. So my advice is that before going to watch this video, you should have a knowledge about that actually. So link will be given in the description. Kindly go through it. Okay, coming to today's class, children. In today's class, mainly we will be talking about the measurement of length. I mean, we are not going to talk about the measurement of mass, measurement of time. Strictly, we will be talking about the measurement of length only. Now, what are the main topics which we are going to cover in this video? So, let us see. The first thing which we will be covering is a least count. Children, this least count we will discuss in general first of all. We'll discuss in general. We'll try to understand what actually least count is. After that only, we will try to talk about the Vernier Callipers. So, under that Vernier calipers only, we discuss what is a Vernier constant and what are the parts of the Vernier calipers and even their uses. I mean, by using different parts, we can have a different applications that will be discussed in detail. And at the end of this session, we will be discussing about the zero errors. Children, this is very important. Usually in examination, if they want to test you about the Vernier calipers, either they are asking about the Vernier constant, and the second one they are asking about the applications of different parts of the Vernier calipers, or the third option is what, children? Zero errors. There only we will be discussing about what is a positive zero error, what is a negative zero error. So these are the main topics today which we are going to discuss. Children, first let us try to understand what actually least count is. First let us see what actually least count, children. So before going to understand this, let us try to think about one word called limit. Let us try to think about one word called limit. Children, this word generally will be using in our day-to-day life also. What will be using, how will be using. So whenever there is a conversation, for example, one serious conversation is going between friends, then they will tell, right, be in your limits. Yes or no? We also will tell, be in your limits, don't cross the limits. What is that? Being in the limits, should not cross the limits. Yes, children. So as a human beings, yes, we have certain limit actually to what extent we have to talk. So more than that, we should not talk, and we cannot talk also even that actually. It leads to a problem. Of course, that is a different concept actually. Now come to our concept actually. Limit means what? You can take any device. I mean to say you can take any device, children. Every device has its own limit, means to a particular extent only, to a particular minimum extent, I mean to say, only we can measure. So below that, we cannot measure actually. So that is actually the concept of least count. First, children, let us take example. When we take example, then it will be a very clear to us. Look at it. First, children, let us take a normal meter scale. Let us take a normal meter scale. Of course, even if you can take a half meter scale also, it's not that we should take a lengthy meter scale only. It is not that. Children, if you can see a meter scale, so for example, it starts with a 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, it is 10. Again it is repeated. Again it is repeated. So we know that from here to here is actually it is a 1 centimeter. Yes, if you want to measure, yes, you can measure 1 centimeter, 2 centimeter, 3 centimeters like that also. But below that 1 centimeter, what is the minimum value which you can measure? Means you can measure this length actually, up to this length. This what, children? This is 1/10 of centimeter, which is equivalent to the 1 millimeter. 1 millimeter. My question is that, can we measure the length by using meter scale less than 1 millimeter, children? Can we measure? No, we cannot measure. So what is the limit of this meter scale now? 1 millimeter. So 1 millimeter is the limit. So you cannot measure the length less than 1 millimeter by using a meter scale. Is it clear? Fine. Now let us take a normal wall clock, children. Normal, I am telling you, normal wall clock. I am not talking about the digital, because the moment when I say this, you may think about, sir, what about a wall clock? Yes, let us see. No, what because the digital watch, you may think actually. But here I am taking an actual wall clock, children. So in a wall clock actually, of course, we can measure the time in hours we can measure. We also can measure in a minutes also. And even if you can see, children, for example here, that long, what we can say, needle will be there, with which we can measure, means seconds also. Means like, you can say that's a, for example, it's a 12 o'clock, 30 minutes, 10 seconds. You can tell. But my point is that, children, can you measure the time by using a normal wall clock? Normal wall clock less than 1 second. Can you use wall clock for athletic purpose, children? No, we cannot use. There will use a digital clock actually, where they will measure even less than 1 second also. But my point is that by using this wall clock, can we measure the time less than 1 second? No, we cannot measure. I mean what? By using wall clock, you can measure in hours. Okay, you can measure in a minutes. And at last you can measure seconds only. But we cannot measure the time less than 1 second by using normal wall clock. So with these two examples, of course, like this we have n number of examples, whatever it may be. But just here we have taken two devices. One is a meter scale, another is a wall clock actually. By using meter scale, children, we cannot measure the length less than 1 millimeter. This is the limit for this. Whereas by using a normal wall clock, we can measure the time up to a second only. So we cannot measure the time by using wall clock less than 1 second. Now here, let us concentrate. Here it is 1 millimeter is a limit. Here it is 1 second is a limit. So now this only I can say that least count of meter scale, and this is the least count of normal scale. Least count of normal scale. Least count of normal scale means what, children? Then how to define? Hope it's clear. Least count means what, children? You can take any device. Every device has its own limit. Means to a particular least value only you can measure. Less than that you can't measure by using that device actually. So that lowest value only you can call it as a least count of that instrument. Means in definition wise, in exam they will ask you a question. Define what is the least count. Then how to write, children? The smallest measurement, the smallest value that can be taken by that device accurately. This is very, very important. Accurately is called least count. I repeat once again. The smallest value that can be taken by any device accurately is called least count of that instrument. Example, least count of meter scale is 1 millimeter. Least count of wall clock is 1 second. Is it clear? Yes. And as I said that in today's class, particularly we are talking about the measurement of length only. Here you may get wonder, sir, then why did you take here time? Actually, to give you more clarity about least count only we have taken. Otherwise, our today target, our task, our discussion is all about measurement of length only. That is fine. Now children, let us continue this discussion only. So this is a meter scale and its least count is 1 millimeter. Which means what, children? 1 millimeter. So this can I write 1 millimeter is nothing but what actually? 0.1 centimeter. Which means what here? By using meter scale, we can measure the up to 1 decimal part of centimeter. But if you want to use, children, if you want to measure the length less than 1 millimeter, can we prefer meter scale? No, we cannot prefer. There only we will be using vernier calipers. We will be using actually vernier calipers. Vernier calipers. So by using this device, actually, we can measure up to 1/10 of millimeter, which means what here? We can measure 0.1 mm or 2 decimals, up to 2 decimals of centimeter we can measure. You may get wonder, sir, how you got this value? Just wait and see. We will have a discussion. But just I am telling you the limit actually, the best device with which we can measure the least value in a length I am talking. Okay, na? So compare with the meter scale, children, vernier caliper is the best. Why? Here you can measure only up to 1 millimeter. But whereas here we are measuring the length up to 1/10 of millimeter. So still we have a situation where we want to measure the length less than 0.1 millimeter. Then definitely vernier calipers is not useful. There only we will be using screw gauge. So screw gauge or screw gauge, different people will spell it in a different manner. It's not a matter. So with the help of screw gauge, children, we can measure up to 0.01 millimeter or third decimal part, that is 0.001 centimeter. Is it clear? Yes. So according to our syllabus, children, we will be having a discussion about vernier calipers and a screw gauge. In today's class, we will be focusing on vernier calipers. In the next classes, we will be discussing about screw gauge. So examination point of view, children, they may ask you to write the least count value. So again, just repeat, meter scale least count is 1 millimeter or 0.1 centimeter. Whereas vernier calipers least count is how much? 0.1 mm and 0.01 centimeter. No need to worry. This we will discuss how we are getting these values. But whereas screw gauge is actually used to measure the length up to 0.01 mm or 0.001 centimeter. Means here, what is the matter? If you can see, children, accuracy is important here. Actually, accuracy is a matter. So means compare with this meter scale, you can take a values more accurately with the vernier calipers. And even when you compare the vernier calipers, you can take the values more accurately in a length with the help of screw gauge. Means what is happening here? If you can see from meter scale to screw gauge, accuracy is increasing. At the same time, think about the least count. Is least count increasing or decreasing? Decreasing. So children, here we can make one relation between least count and accuracy. Children, examination point of view, it's very, very important. They will ask you a question. How are you going to increase the accuracy of a device which you are going to use actually? There you should talk about the least count. By decreasing the least count, we can increase the more accuracy. Okay, so we can write like this, least count or else accuracy. Okay, what is accuracy? Okay, let me write here. So here accuracy is inversely proportional to the least count. Children, make a note of it. It's very, 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 very important actually. So here its evidence is there. Here we have evidence. So from meter scale to screw gauge, least count is decreasing. Simultaneously, what is happening? Accuracy is increased. That is what actually we are using, right? We want to measure the values more accurately. For that only we are going for a better devices. Is it clear? Just copy it. We will see about, we'll be talking about especially vernier calipers. Now we'll discuss about vernier calipers. Children, once again we need to remember one important point. What is that? By using vernier calipers, children, we can measure the length up to 0.1 millimeter or we can measure up to 0.01 centimeter. So we will see actually how we will get this value also we'll discuss. Children, this value is not the same for all vernier calipers. It's not that. It can be different. So I'll tell you how this value is going to be different also. But in today's class, we are going to talk about only one particular vernier calipers whose least count is 0.1 millimeter or 0.01 centimeter. So let us come to this vernier calipers, children. So here vernier calipers mainly consisting of two scales. Children, vernier calipers is a special type of device where we are going to use two scales, means we combine two scales to have a better value to increase the accuracy. Okay, now fine. So the first one is main scale, children. First one is we have main scale, and the second one is Vernier scale. Second one is Vernier scale. Second one is Vernier scale. Now let us see how this main scale and the Vernier scales are calibrated, so that it will be very easy to us to understand the Vernier constant and how it is calculated. Children, here main scale is nothing but the normal, that is ordinary scale only. But here it is made up of with a metal strip on which so the scale is calibrated. So if you can see here, it is like a normal scale only. It is like a normal scale only. So it is calibrated in, let's say, from 0 to like a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let us say from here to here, let us say 1 centimeter. Again here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is continued actually. This is continued actually. So this is how actually main scale will be. Now children, it's very important thing is that here. Now if you can see I am highlighting the distance between these two lines, children. So this we know that from here it is a 1 millimeter. So this only we are going to call it as a 1 MSD, that is main scale division. Main scale division. So children, here 1 main scale division is equal to 1 millimeter. Am I clear, children? Which means what? By using this main scale, you can measure the length up to 1 millimeter only, which is we can call it in that, which we are calling it as a 1 MSD. 1 main scale division is equal to 1 millimeter. Is it clear? Fine. Now the very important thing is that then how the Vernier scale is what we can say designed. Children, this is the point where we have to concentrate more. Children, our intention is just to know, just to calculate the least count or its Vernier constant. It is not that. Our intention to understand the concept, because in exam, if they will change the number of divisions in a Vernier scale also, we should be in a position to calculate the least count of that Vernier scale. I mean that Vernier calipers. This is our actually intention. So let us see, children, here. So for suppose here, let us say Vernier scale. Children, just for sake of convenient, just I am making this much big Vernier scale. Otherwise, you know, in reality it will be very small actually. So we need to look into that divisions also with so much of care actually. Otherwise, you know, it's too difficult to see. Okay, na? Fine. Look at here. So Vernier scale here. How many divisions will be there in a Vernier scale is the question actually. So I have seen some students are saying that yes sir, my particular teacher said that yes, always there are 10 divisions only. Of course, the teacher might be right only in terms of that given Vernier calipers actually. Otherwise, children, it is not compulsory. I think the particular teacher might have spoken in general. So of course, in general, it will be 10 divisions we will take. It is not that compulsory it is 10 divisions only. You can change the number of divisions actually. Okay, children, it can be 10, it can be 15, it can be 20, it can be 25. You can make actually. You can change. When you are designing, when you are making Vernier calipers only. After making, once Vernier calipers is made, we can't change. It is not in our hand to change it. While it is, you know, it's during what we can say manufacturing only, they have to do it actually. But usually, children, we will be using, normally in our schools, we will be using a Vernier calipers, which will have 10 divisions actually. But again, I am telling you, it is not compulsory that it should have a 10 divisions. Okay, na? So for say our convenience, let me draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us say. For suppose, children, let us say here these are the n divisions. Let us say these are the n divisions. So n can be 10, n can be 15, n can be 20, n can be 25, whatever it may be. Okay, na? Fine. Once again, let us see what is the principle of actually Vernier calipers, children. So here it says that actually n Vernier scale divisions is equal to the n minus 1 main scale divisions. This is very important. So equating the n Vernier scale divisions with n minus 1 main scale divisions. But how to understand this? How to understand this is a very important. For suppose, children, here I have taken, for suppose, here I have taken a Vernier calipers, what I say, scale divisions are 10. Then it is going to be a 10 VSD is equal to 10 minus 1 MSD. I mean what here? 10 Vernier scale divisions is equal to 9 MSD. Children, what is MSD? 1 millimeter, which means what here? 10 Vernier scale divisions is equal to the 9 millimeter. Isn't it? 9 millimeter. So 1 VSD is equal to 9 by 10 millimeter. This is 0.9 millimeters. This is 1 VSD value. 1 VSD value. Children, this is how in a simple manner we can understand. So here again I am telling you, here we have chosen only 10 division scale actually, which means what here? 9 millimeter length of main scale division is equal to the 10 divisions of Vernier scale actually. Is it clear? Fine. So means what, children? This each division of Vernier scale only we can call it as a 1 VSD, which is equal to the 0.9 millimeter. 0.9 millimeter. Children, these two things we should remember. These are very, very important. So, one main scale division is equal to 1 millimeter, but whereas one Vernier scale division is equal to the 0.9 millimeter. Now, how to calculate the least count of Vernier calipers? Children, here least count of Vernier calipers is equal to 1 MSD minus 1 VSD. So, this is a formula which we use to calculate. So, children, here we know the value of 1 MSD, 1 VSD, right? So, here 1 MSD is equal to what? 1 millimeter minus 1 VSD is what actually? 0.9 millimeter. So, this is going to be 1 millimeter minus 0.9 millimeter. This is going to be a 0.1 millimeter. So, children, this is how actually we got a least count of a given Vernier calipers where there are 10 divisions in a Vernier scale. Children, I am talking about the Vernier calipers in which there are only 10 divisions in Vernier scale. Try to understand. So, 0.1 millimeter or it can be 0.01 centimeters. 0.0 centimeter. Okay, just copy it. Children, here you may get a one doubt. Sir, for suppose in exam a Vernier calipers is given in which Vernier scale is having 20 divisions, sir. Then how to calculate? Children, for that we have one general formula in order to calculate the least count of any given Vernier calipers. Just copy this, we will discuss that. Okay. Come on, copy it. 3, 2, 1. Done? Chalo. Now, children, let me discuss in general. Now. Look at here, children. Look at here. So, this is what actually I said. N Vernier scale divisions is equal to the n minus 1 main scale divisions, children. For suppose, children, one main scale division, let us assume as x. X is what? 1 MSD. Of course, we know that is a 1 mm only, but for sake of our convenience, for some time, let us say that 1 MSD is equal to the x. Its value, I mean to say, 1 MSD value is x. Now, then what will happen? N VSD is equal to n minus 1 into x. Isn't it? Fine. Now, here 1 VSD, V not DS, sorry, is a Vernier scale division is equal to n minus 1 by n into x. I mean this n I have taken this side. Clear? So, it's very clear, children. 1 VSD value we have and 1 MSD we assumed as a x. But how to calculate least count, children? Least count is equal to 1 MSD minus 1 VSD. Let us substitute this. 1 MSD is x, children. 1 VSD is what? N minus 1 into x by n. Let us take a LCM for this. This is going to be a n. This is nx. Let us simplify this, children. This is going to be a minus nx plus x. Nx cancel. So, here least count is equal to x by n. Least count is equal to x by n. So, that is what we got, children, here. Least count is equal to x by n. You may get a one doubt. Sir, then what is x, what is n? Children, just we got x is what actually? X is 1 MSD, which is equal to the 1 millimeter. That is 1 mm. 1 mm. What is n, children, here? It is number of Vernier scale divisions. number of vernier scale divisions. So example children, for what we have taken, we have taken, so according to our scale children, n is what actually here? N is 10 divisions which we have taken. Now substitute here, least count is equal to x is 1 millimeter, n is 10. So this we are getting 0.1 millimeter. Yay, we got it. We got 0.1 millimeter. For suppose in an exam, if it is given that vernier scale has 20 divisions, then what you have to do? In the place of n, you have to substitute 20. You will get that related least count. Children, again I am telling you, least count is a fixed for a given vernier calipers. It does not mean that each and every vernier calipers has the same least count. It is not that. It can be changed. But how? By changing the number of divisions in a vernier scale only. So children, so this is what actually about a main scale, vernier scale, and how to calculate the least count. Of course, this only we also can call it as a vernier constant. So in exam they may ask you to how can we calculate what vernier constant, or what is a vernier constant. Vernier constant is what actually it is defined as the difference between one MSD and one VSD, which is equal to in general for a vernier calipers in which vernier scale has 10 divisions. In that case children, the least count is 0.1 millimeter or 0.01 centimeter. Is that clear? Fine. Now just copy this. We will see how the vernier calipers is going to be and what are the parts and what are the applications. I mean how different parts of vernier calipers are used in a different manner. Okay children, just copy it. Fine children. Now with this knowledge, it's very easy to us to calculate length of length of any given object by using a vernier calipers. So children, let us see actually first how the parts of the vernier calipers will be. Children, as I told you that here, so vernier calipers has a scale like this, that is the main scale. So here is main scale children. So are you able to see it? Okay, fine. So this is calibrated matrix. Let us say it's a 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, this is 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, that is 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So of course like this it will be there up to 10 centimeters or 15 centimeters, depends on the vernier calipers how we are going to make. It is not fixed that should have till this number. It depends actually. Okay, fine. So children, this is actually main scale. Main scale is what, as I told you, that it is a metallic strip, a rectangular metallic strip on which a scale is calibrated so that one division is equal to the 1 millimeter. And here for this what we can say a main scale, left side one jot, right? So this we can call it as a fixed joint. It's a fixed actually. It won't move actually. It can't be slided. It can't be changed. This position is a fixed actually. Let us name it as a J1. Okay now. And similarly this side only one more jaw will be there. This. So let us say it is a J2. So this is upper jaw, it is a lower jaw. But the thing is that these two are fixed actually. J1, J2 are fixed. Okay, children, fine. And here, what about a vernier scale? Children, vernier scale is a design such a way that it can be slided over the main scale. Okay, so it will be like this. Let me erase this number so it's very easy to us. So it will be, first let me draw so that we can change afterwards. Let me change. Okay, so this is how actually vernier scale is going to be. It can be slided. Okay, so for this two more jaws will be there. Let us, okay, and here is that's fine. Yeah. So children, this is how actually we can make. So here you can name it as a J2 and is a J4. Children, if you can see, This is actually Vernier scale now. Again I am telling you, it's a Vernier scale. This is a Vernier scale on which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions will be there. Try to understand. Try to understand. So this Vernier scale is slided over the main scale, and here this J2 and J4 are fixed to this Vernier scale. As the what we can say Vernier scale is movable, along with what will happen, this J4 and J2 also movable. So that's what we can call it as a J1, J2 are fixed jaws, but whereas J2 and J4 are movable jaws. And also we have named children J1, J2. These are all called external jaws. Very, very important. External jaws. Whereas these two are called internal jaws. These two are called internal jaws actually. So by using external jaws, children, we can measure the length of an object. We can measure the length of an object, or we also can measure the external diameter. External diameter. But whereas by using internal jaws, children, we can measure the internal diameter. Internal diameter can be measured. For suppose, children, if you have water bottle, that cap will be there. If you want to measure the external diameter of that water bottle cap, we can use the external jaws. But whereas if you want to measure the inner diameter of that water bottle cap, there we have to use actually internal jaws. Is it clear? Fine, children. And here for this Vernier what we get scale only, here one screw will be there, either here or here. One screw will be there. Let us name it the S. What is the purpose of screw, children? As I told you that this Vernier scale can be slided. So with the help of this scale, what we can say, this screw S only, we can fix that Vernier scale at a given fixed position on main scale actually. Is it clear? Fine. And here at the what we can say, one more important point, children, as we are sliding actually this Vernier scale, behind of this actually, now it's not possible to show me on board actually, behind this, what we can say, a main scale, one metallic strip will be there, which will be attached to this Vernier scale. As a Vernier scale is just taking near, what we can say, far from this fixed jaws, backside what will happen, one metallic strip which will be coming out. Actually. So this only we can call it as a tail, which we can call it as a tail. What is the purpose of this, children? With the help of this tail, children, we can calculate the depth of a given vessel. I mean, depth of given vessel means not like a large or huge vessel. For example, test tube will be there. If you want to find the depth of the test tube, so there we will use this tail only. So depth of test tube, example I am telling you, depth of test tube actually. Is it clear? So children, these are the main parts of Vernier calipers. These are the main parts of Vernier calipers. Again I will tell you, children, again I am telling you. So this is a main scale, this is main scale, and this is a Vernier scale which can be slided over the main scale. Whereas here J1, J2 are the fixed jaws, J2, J4 can be slided along with Vernier scale. That's what J2 and J4 are called movable jaws. So external jaws which are used to find the length of an object, means the object is placed. So between these two external jaws which will be held and which can be whose length can be measured. Whereas J2 and J4 are called internal jaws with which we can measure the internal diameter. Whereas here is a tail, metallic one. So with the help of that tail we can measure the depth of a given test tube like a things actually. Is it clear? So just you try to just make a rough diagram of Vernier calipers, children. Now we discuss actually what is a formulae and how to take the main scale value and how to take the Vernier scale value. Okay children, just copy it. Fine children. So we'll just for example to determine the, look at here, to determine the length of a given object, cylindrical object, anything children. But children here, before going to actually calculate the length of any object, it may be length or it may be inner diameter, it might be external diameter, children. First we should check whether that particular vernier calipers has any zero error or not. So if you want to find whether it has a zero error or not and what type of zero error it is, first we should understand what is zero error. Children, examination point of view, this is a very important. So before going to determine the length of a given object, first let us calculate, let us understand what actually zero error, Children, to check whether is there any zero error or not in a given vernier calipers, what we have to do, children? So here we have to bring, actually. So children, there are external jaws will be there, that external jaws to be brought in a contact. The external jaws to be brought in a contact. You may get wondered, okay sir, we will bring external jaws to be in a contact, but still how can we? Just let me tell you, children. So for sake of our convenience, let me just make a simple diagram. Simple means very simple diagram I will make. So here almost as I told that both are coinciding. So here is this vernier calipers. Let us say here like this. Okay. So of course here that external jaws, this will be there. So here that vernier scale will be there. In a rough diagram I am making, children. Here one screw will be there. It's a tail, something like this. So here what we are doing here, we are bringing two external jaws in a contact, so that we need to check one important point. So what is that to be checked? Look at here, children. Here main scale has zero reading, right? Main scale, yes or no? Yes sir, main scale has zero reading. And even in a vernier scale also zero reading will be there. Yes. For suppose, children, here this is a zero reading of the main scale and this is the zero reading of the vernier scale. It's a vernier scale. This is zero reading of the main scale. So here in this case, for suppose we brought two external jaws in a contact such a way that what happened, the zero reading of the vernier scale is coinciding with the zero reading of the main scale. If it is a coinciding, children, then it is said to be has no zero error. It is free from zero error, children. It is free from zero error, and directly you can use that vernier calipers to calculate, to determine the length or inner diameter or external diameter or depth of any test tube. Directly you can use actually. So this is a case, again I am telling you, even I am trying to show you on board also the picture, so that it's very clear to you to understand. So that is a case I am telling you. So this is a case where zero, I am telling you, zero reading of the vernier scale is coinciding with the zero reading of the main scale. Then we can say that there is no zero error. But problem comes if zero reading of the vernier scale won't coincide with the zero reading of the main scale. Okay, children. So this is the case. It's very clear where it is coinciding, so that there is no zero error, there is no headache. Directly you can use it. Fine. But what if it is not coinciding? Again, if it is not coinciding means we'll get a wonder. It is not coinciding means what? The zero reading of the vernier scale can be left side. Yes, it is possible. Can be even right side also. So based on that only, we have two types of zero errors, children. We have two types of zero errors. Let us see. We have negative zero error. Now let us see what is a positive zero error. When you can say that given vernier calipers has positive zero error, how it can be corrected, children. So for suppose, children, again I am telling you, let us say this is a zero reading of the main scale, children. It is a zero reading of the main scale. Okay, now. So here we brought two external jaws in a contact, but it is not coinciding. What is not coinciding? Zero reading of the vernier scale is not coinciding with the zero reading of the main scale. So it's very clear that it has a zero error. But what type of zero error? Where that zero reading of the vernier scale is standing? Is it standing right side of the zero reading of the main scale, or it is standing left side of the zero reading of the main scale? For suppose, children, if that zero reading of the vernier scale is standing right side of the zero reading of the main scale, it is said to be has positive zero error. For that children, correction is negative. For that, correction is going to be negative because as it is extra value it has, so that should be deleted. Of course, in detail, we'll understand when we do a practical only. So again, I'm telling you, when a Vernier calipers has set to has a pass zero error. So when two external jaws are brought in a contact such a way that zero reading of the Vernier scale is standing or is standing on the right side of the zero reading of the main scale. So it is said to has positive zero error. If not, children, one more chance is there. Here let us say it is a zero reading of the main scale. Zero reading of the main scale. But here, after bringing the two external jaws in a contact, we notice that zero reading of the Vernier scale. Zero reading of the Vernier scale is standing left side. Is a left side of the zero reading of the main scale. Okay, now then it is said to be has negative zero error, children. For this, correction is positive. So children, this is what actually we need to understand. Actually in detail, in the 11th class standard, in detail it will be understood actually. In detail will be discussed. So as per our syllabus, children, just we need to understand what is a positive zero error, what is a negative zero error. Children, let me repeat. So when we bring two external jaws in a contact, if the zero reading of the Vernier scale is coinciding with the zero reading of the main scale, so it is said to has no zero error. If it is not coinciding only, it is said to be has some error. Is it clear? Fine. If the zero reading of the Vernier scale is standing on the right side of the zero reading of the main scale, it is said to has positive zero error, correction is negative. Whereas if the zero reading of the Vernier scale is standing left side of the zero reading of the main scale, then it is said to be has what, children? Negative zero error, and the correction is positive. Is it clear? Fine. Now we will try to determine the length of a given object by assuming that there is no zero error. By assuming that there is no zero error. Let us see once again, children. So let us see for that what is the formula to be used to calculate or to determine the length of an object. So look at here, children. First, suppose I think for this we need to make a diagram. Let us see. So let us say it's just it will be extended. Okay, just example, children. This just is example. It is not exactly actually. So what we have done, children, what we have done here. So a given object, cylindrical object is given. So what we have to do, just we have to keep in between these external jaws, and we have to bring this scale so that what will happen, this object should be held tightly in between these two external jaws. After that, we have to fix this screw so that it can't be moved, so that it can't be, what will happen, it won't fall actually. It is fixed, it is held properly. Fine, children. Now what is formula to calculate the what we can say length of an object, children? So here length of an object is equal to main scale reading plus Vernier scale reading into least count. Children, I'm telling you that we have taken a Vernier calipers in such a way that it is a free from zero error, and whose least count is calculated already. The least count of this is 0.1 millimeter or 0.01 centimeters. Fine. And our task is only one thing: how to take the main scale reading and how to take the Vernier scale reading. That's it. Now look at here, children. So children, this is actually what, it's a zero of the Vernier scale. Is it clear? Fine. First, what is a main scale reading? It's very, very important. So here, just let me talk in a simple manner. I'm talking, not in a scientific words. In a simple words, I'm going to talk here. Just look at the zero reading, children. Just below this, whatever the reading is there, just below the zero reading, whatever is there, that is going to be a MSR. So if you can see, this is 2, in between 2 and 2.1. But which one we should take? You can't take a 2.1. You have to take a 2 only. So here MSR value will be 2 centimeters. Again, I'm telling you how to take a main scale reading, children. So the reading on a main scale just before the zero reading of the Vernier scale, just before zero reading of the Vernier scale is going to be a main scale reading. That is fine. It's very easy only. But children, here the understanding VSR, Vernier scale reading, is very important. It is not so easy. So here definitely it varies from person to person also. There will be some parallax error also here. Okay, no problem. Let us not talk about that. In general, let us see here. See children, if you can see here 10 divisions on Vernier scale. Let me draw here. For suppose children, these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Children, this is, let us say, it's a Vernier scale. And here obviously it's a main scale will be there. Here main scale. For suppose here it is said that this is 2. Children, again I am redrawing just to give a clarity. Okay now. So here for suppose children. So after that it is given like this. Something like this there. So we have to see children. Here 10 divisions are there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of this 10 division children, only one division only will exactly coincide with the one of the divisions of the main scale. For suppose you are seeing, for example telling you, let me tell, okay, for me the sixth one is coinciding, let us say, exactly sixth one is coinciding. So what is that number of division in a Vernier scale is coinciding with the number of division of the main scale. That number you have to see, either sixth one is coinciding or seventh one or eighth one, whatever it may be. For example, for your friend, you may tell that, hey, fifth one is coinciding, Ray. Or you may tell, no, it is sixth one is coinciding. No problem. You can let your friend take a fifth one. Of course, sometimes too difficult. I said it depends on our eyesight also. That is what actual errors which we learning in a 11th class. The types of error, how the errors can be eliminated. Of course, we will be discussing in 11th class. That is different. So for this actually, let us try to find out the number of the number of division which is coincident with the number of divisions in a main scale actually. For suppose for me the sixth one is coincident, let us say. Then here Vernier scale reading is going to be 6. Don't write 6 millimeter or 6 centimeters. No. Now let us substitute here. So length is equal to MSR is what? 2 centimeters plus VSR is 6. Least count should we take a 0.1 millimeter, 0.01 centimeter. Children, it's very, very important. As we have taken MSR in centimeters, you must take in centimeters only. So this is going to be 0.01 centimeter. Now you calculate 2 plus 6 into 0.01. This is going to be 2 plus 0.06. This will be 2.06 centimeters. So this is the length of a given object, which means what? We are measuring by using Vernier calipers up to 2 decimals of centimeter. That's very, very important. Whereas by using the main scale, we can measure only length up to 1 decimal of centimeter only. Here 2 decimals of centimeters we are measuring. Is that clear, children? So this is what actually Vernier calipers and how to determine the length of a given object. Children, examination point of view, they will ask you what is the least count. Children, what is the least count, children? Here the smallest measurement that can be taken by any device accurately is called least count. So the least count of Vernier calipers is 0.1 millimeter or 0.01 centimeter. Children, least count and accuracy, how both are related? Accuracy is inversely proportional to the least count. As the least count is decreasing, accuracy will be more for that given device. Okay, fine. Next, even what we discussed about how to calculate the Vernier constant. Children, again I am telling you how can we change the least count of a Vernier calipers, children? By changing the number of divisions in a Vernier scale only, we can change the least count of a Vernier calipers so that accuracy will be changed. And what are the main parts of the Vernier calipers, children? If you can see, here is a main scale, Vernier scale, what we can say, external jaws, internal jaws, screw will be there, and backside here metallic, the tail will be there. And what are the application, children? By using this external jaws, we can find the length of a given object, and also we can find the external diameter. By using this internal jaws, we can find the what we can find, children? We can find the internal diameter. By using this metallic tail, we can find the depth of a given, what we can say vessel, such as a small like test tubes. So these are the parts of the vernier calipers and their applications. And again, I'm telling you, before going to determine what the lengths with the help of vernier caliper, children, we need to check whether there are any errors or not. So what is a zero error, children? When you can say that that particular vernier calipers are free from zero error, if you can bring these external jaws in a contact such a way that if the zero reading of the vernier scale is coinciding with the zero reading of the main scale, then it is said to be free from zero error. If it is not coinciding only, we can say that it has some zero error. If the zero reading of the vernier scale is standing on the right side of the zero reading of the main scale, it is said to be has positive zero error, correction is negative. If the zero reading of the vernier scale is standing on the left side of the zero reading of the main scale, it is said to has negative zero error, correction is positive. And what is the formula to find the length of a given object, children? Here length is equal to MSR plus VSR into LC. So children, so these are the today's topics. Hope it's very clear. Children, once again I'm telling you, of course you might have listened and everything is okay, that's fine only. But children, don't forget to read the textbook. First priority you must give for a textbook only. Again and again I'm telling you. Kindly read the textbook first. That is very important. Then come back to the video. Then you watch. Children, again here also I will tell you, I never force any student to watch our channel. It is not that. Because if you think that it is useful, you will watch and you will suggest your friends also even to follow our channel. So just our intention, our channel intention is what? To make the students to understand the concept. We are not trying to teach you what is the question, what is the answer. It is not that. We are trying our level best to make you to understand the concept. Because what is the main plan is that here, children. So if you can understand the concept, children, no need to teach you what is the question, what is the answer. This is a numerical, this is a solution. No, you only can solve on your own. So if I can, solve one numerical, my students should be in a position to solve many numericals on their own. Because the questions, whatever we are practicing, may not be asked in exam, children. Can be some new numericals also, but concept is not new. So once you can get the command and the concept, children, you will be in a position to answer any type of question. There you won't think about whether question paper is going to be tough or easy. Because you are okay with the concept, you got a command and the concept. Obviously, you will be in a position to solve or to write any type of question or any type of numerical. Okay, children, for that, what you have to do, just read the textbook. While reading the textbook, just try to make your own notes. And children, whenever you are reading a textbook, if you get any doubts, again I'm telling you, you can note down, and if you have a time, if you are watching our channel, yes, you can put in a comment box so that we'll try to answer all your doubts. Okay, children, thank you so much. All the very best.